In this podcast, we're going to follow up to some of the questioning and the discussion that went on in class today regarding the properties of the dot product. And once that's done, we'll end up calculating dot products. From your textbook, these are some of the properties you investigated and explored. Properties 1 through 3, and then properties 4 and 5, we attempted to apply them to a couple of examples, which you'll see on the next slide. And all of these slides, I believe I did post to the course website in the event that you'd rather have a copy of those prior to watching the video. Now, I did not retain the ink notes from our class, but I do recall some of the discussion and some of that back and forth that we had. And when I look at the first part, and this is one of those moments where you just have to kind of shrug your shoulders and say, really? If you consider that expression there, okay, so u dot, and here we are in brackets, k u dot v. What we have to remember is that the dot product is an operation performed on vectors, and the result of the dot product is a scalar. So what I'm going to do, I'm just going to record a few notes. I'll probably erase them after the fact because I need the space for whatever work has to occur. But if you consider the following. Okay. At the end of the day, okay, if we think about it, when you actually work with KU, okay, you're performing a scalar multiplication of the vector u. So that really doesn't affect the vector itself, it just merely stretches it out. So it's still a vector, or it compresses it depending on the value of k. So it simply scales the vector, it's still a vector. Okay, so really we have a vector. And what are we doing with that vector? Well, we're applying the dot product, right? So we have a vector dot product. The result of that dot product is a scalar. But here's the conundrum, right? What do I do now that I have the vector u and I'm being asked to perform a dot product, right? Well, I'm here to tell you that that's just not going to work out, right? So it's just not possible. I'm just going to grab an X here and just to say that that's a no-go. Okay, the reason why is that the dot product is a vector operation that produces a scalar quantity, or produces a scalar, in short. So when we are trying to determine the dot product of a vector and a scalar, it does not exist, okay, because the dot product is a vector operation. So this does not exist. So it begs the question, well, why did you put that one there? Well, I'd like to say it was out of humor, but the reality is that there is an error in the expression. Okay, so why don't we piece this together? So ultimately, if we want to be able to perform the dot product, which is a vector operation, we need to change the definition of the expression we're working with. And actually, this is a good exercise, even though it's not going specifically the way it was intended to. It will actually reap benefits in an example later on. Whoops, that's not what we want to do. Bring that back. We want to add. Okay, we're going to put an addition symbol in between those. This, ladies and gentlemen, is what we need to have. Okay? So hopefully everybody got that announcement regarding student council nominations. So we're getting back to part A. We're going to apply the distributive property. Okay, we had begun by trying to apply the associative property to the expression that was incorrect. That was a good first move for us, but it made it very difficult to move beyond that. So we can apply the distributive property for the dot product. And we didn't get a chance to prove that one, but the distributive property does hold true for dot products, much like it does in the other cases of where you've used the distributive property in the past. So for instance, in this first one, what we can do is write it as k and then u dot u. Okay, so really what we're doing is we are distributing the vector u over ku, and the operator, or the operation between the vectors, is the dot product. Well, following that, what we'll do is take a hold of the addition sign, and we will then again distribute the u over the v. Okay, so distributing the u over the v, and the reason being, or the ability that we have to do that, is because of the operator that's there. It's not a multiplication. Okay, it's a new operation. It's the dot product. So we'll throw in the dot product symbol. That is our operation. Okay, so moving forward, we just apply the distributive property, and we now know, as proven in class, that the product of a vector, dot product of a vector in itself is simply the magnitude of the vector squared. Okay, and there you have it. So with a little additional practice in incorporating the dot product and the distributive property, you'll be able to solve a variety of these examples. So let's move on. Let's try this one out. Okay, part B. I'm going to leave these notes here. I'm just going to insert a slide, go back, copy this one here, and we'll bring that forward, and we'll paste that into place here. Perfect. Now, with this one, you'll notice that we have the same two vector differences, and it did come up in class. Okay, there are a couple ideas being batted around, but I know that one specifically was, is this true? Okay, and I believe that we did agree that yes. Okay, because if we were to allow u minus v to be some other vector, call it a, then we would see that a dot a would be equal to the magnitude of a squared, right? And what does that imply? That implies, right, because of the transitive property and how we let u minus v be a, that u minus v dot u minus v has to be the magnitude of u minus v squared. So I forgot to put that up here. That needs to be present, okay, in our proof. So that is very well true. The problem is that if we didn't have this definition, right here, is there some other way that we could come at this and prove it? So there is another way, and what's going to happen is we're going to have to go through part of it, but we'll have to put the brakes on because there's a lot more mathematics involved, a lot more theory behind working with expressions such as these. This may not be the time and the place for it. Okay, so we might cover more of it in class, or I'll post another video that will speak to that. So let's move forward with this one. Okay, so I'm just going to consider what's above the line to be rough work, and then below that we'll move on. Okay, check our running time. We're up to about 10 minutes, so to incorporate the other examples, I'm going to have to film a couple of these, perhaps maybe 3 at most, so they're short and manageable chunks of information. So let's consider the dot product of these same 2 vectors, okay, in another light, and let's apply the distributive property, okay? There's 2 ways we can view this. What we can do is we can start by taking all of the first quantity and determining the product or the dot product it has with the first vector, okay, in the second vector difference. To that, when we were using the distributive property, even years ago, what would then happen is we would then take, right, we would then add on that same first quantity. Okay, so I'm just going to highlight some stuff here. Okay, so we have all the parts in place. We would take that same, in this case, vector difference or vector, and we would apply it to or distribute it over the remaining piece, okay, which we have here as the minus v. And then our operator, of course, is the dot product. That's the operation. Then moving forward on that, we can then apply the distributive property once more. Okay, so in this case, we're going to be looking at u dot u. Okay, so again, let me try to highlight here a little bit more. So it's taking this vector here and distributing it over that one there. Of course, the operation is not multiplication, it's the dot product, which we see here. Okay, so moving forward after that, we would then have to take, okay, the second quantity. Here we have negative v, and I meant to put that in a different color. Let's see if I can do that. That's better. Good. Okay, so let's do that. And we're going to have to distribute over that. So we're going to end up with, that would be minus v dot u. Okay, so again, let's connect that with the colors here. So minus the v distributed over the u. And of course, we're determining the dot product. To that, we're going to add on. Okay, same thing. Let's do some distributing here. Let's start with the first one. So it's going to be u over minus v. So we're going to have u and then dot minus v. And then last but not least, what you're going to notice is the following. We'll take minus v, distribute that over minus of v. So really, we have the 2 negatives. Same rule applies here. And we're going to end up with, we're going to add on v dot v. Okay. So at the end of the day, notice that we have u dot u, which of course is none other than the magnitude of the vector u, and that's squared. At the end of it all, we also have v, the dot product of v and itself. So that would be the magnitude of v squared. And in the middle, I'm just going to go off to the right-hand side here and do just a little background work. Okay, just in the margin. This is not a part of the solution. Okay, so just over here, what we want to take note of is that minus v dot u, okay, is also equivalent to the minus of u dot v. Okay, so we can do that using the associative property. Okay, and then we also have the following statement. So u dot minus of v, again, that's also much like saying the minus of u dot v. Okay, so we can switch the order of the terms. We can change the position of the negative. So knowing that, means that back here in the final answer, we really have 2, right? Minus 2 u dot v's, okay? This is specifically what we have as an answer. And that concludes this portion of the lesson. One other thing is that you might find it more efficient, as if we couldn't get any more efficient, to actually start with this line and then move right into here. Okay, so you may not have to start with the given line here, okay, but you might want to actually move all the way down into that one there, okay? So you should see a second video going up in the next little while, and it'll focus on some other examples.